Hey there, spacers. Welcome to the Space Revolution. This is Rick Tumlinson. I'm your host. You're listening to iRock Space Radio. We're a subdivision of iHeart Radio Network. Hey, we have an amazing guest tonight. I love it when I get people on the show that kind of have a background similar to mine, which is an everything and nothing background. They are experts at everything, or partial experts. Although in the case of our guest, you're going to find out he's actually a real expert. What I call a Renaissance dude. And so for the background here, his name is Jonathan Knowles. Now, you may not specifically have heard of Jonathan, but you've heard of and used and worked with many of the different things that he's been a part of, that he's helped create or helped develop. John started UC Irvine, Harvard Kennedy School, Cornell University. He was in the early days of Apple, worked with Adobe for many, many years, part of Autodesk also for many years. He has been involved with oceanography. He's a member of the Explorers Club, on and on and on. And the best way, I think, to deal with this sort of confusing and vast resume is to just actually dive in and have what I think is going to be a fun conversation with John. Jonathan Knowles, welcome, sir. How are you?
Hey, Rick, it is always a pleasure to talk to you. It's been a few months since we saw each other in person down in Ojai, and I'm so happy to be here. And congratulations on this radio show and podcast. I've been listening to them. And you just had my friend Pete Garrison on.
Yes,
As
Colonel
a matter of
Pete.
fact, I have just started reading Pete's book. It's great.
Yeah,
I
it's
knew
great.
Pete when he had just become Garrettson, excuse me, Major Garrettson.
Yeah, he was what I used to refer to as one of the young colonels, who's not so young anymore.
Right.
But yeah, I should mention John and I met at a little thing. This guy with the bookstore, Bezos, somebody throws in Ojai, called Mars, which is not about Mars. And I'm going to get this wrong: machine learning, uh,
Automation.
automation, robotics, and space. And it's an amazing weekend. Happens every year. John is an alumni. I've been twice, but we just had some amazing conversations. And I remember at the time saying, "I have to get you on the Space Revolution." So Jonathan, right now, your main gig, one of many. And by the way, I really admire people who can turn ADD into an actual life description. So anyway, your main gig right now is you're working with NASA Ames, and you're the exploration director. Tell us what that's about.
Well, it's actually a NASA headquarters program.
Mm-hmm.
We had traditionally been doing a lot of the work at Ames. However, nowadays we are dispersing where that work gets done. So it's the NASA Frontier Development Lab. And we are in our 8th year. And the NASA Frontier Development Lab is an AI research accelerator that is focused on working on some of NASA's most difficult and important challenges. As I said, 8th year. Our very first work was done on a variety of domains, and over time we continue to work in these domains and occasionally add other domains along the way as dictated by the Science Mission Directorate at NASA headquarters. So
Yeah, go ahead.
some of those domains, so planetary defense 8 years ago. For those who've looked or seen the movie, don't look up. We were using machine learning to better understand orbital trajectories of asteroids, as well as spin and composition, and the role those play on the things we might do to mitigate the potential disasters. And that was very successful work. And of course, machine learning is very good at predicting things. And in that domain, prediction is what a lot of it is about. We've always worked on, or we have worked on since the beginning, Heliophysics, so solar physics, the physics of our sun, kind of a big deal. Haha, yeah, bad science joke. Um, and pretty much everything has to here is in some way, in all ways, affected by what the sun is constantly doing. And we've come a long way just in the last 20 or so years, but especially in the last 8 years, with better understanding how the sun works, and better at, again, using machine learning to predict some of the things that it might do. And that can be very important for a lot of reasons. People who tune into this might be familiar with the Carrington event, the mid 1800s. It is what we now refer to as coronal mass ejections, when the sun spews out not just radiation, such as with solar flares, but actual radioactive matter at extremely fast speeds, but not the speed of light, so that we might have 14 or more hours notice that this blast of radioactive matter is heading in our direction. Because as the sun increases in activity, lots of things can happen here on Earth. Of course, pretty things can happen, like our aurora, our northern and southern lights that we can see. These various events on the sun can also affect things on planet Earth, such as power grids and other sensitive electronics. They can absolutely affect the many things that we have in orbit these days, not only from the blasts of radiation, but also from things like increasing thermospheric drag. So as satellites are orbiting in orbit, the satellites that are closer to the Earth, lower to the Earth, as the atmosphere expands and contracts, as things heat up and become more active because what the sun is doing, satellites can get into trouble. As a matter of fact, I might have these numbers wrong, but I think about something like 40 of the 70 satellites launched not that long ago by SpaceX for Starlink. I don't know if it was a SpaceX launch. I'm sure it was. Might not be. But they were lost due to inaccurate predictions of future thermospheric drag. And there's many other examples of this. And that also leads to another thing that we work on, and that's astronaut health. If we are going to have a future as humans in space, we need to better understand how we creatures who, after billions of years, have evolved here, not up there, can not only survive but thrive. And the reality is, it's very dangerous in space. You are exposed to lots of radiation. There are all kinds of things we need to consider, things like bone mass, muscle mass, and so many other things. And we're learning more and more all the time about what we need to pay attention to and focus. How can we use rapidly accelerating technologies, for example, machine learning, to help address some of those things? And of course, as we are now building out starting to think about building out a solid cislunar strategy, possibly economy, let alone going to Mars. Well, there are lots of things we need to pay attention to make sure that that we can survive doing that. We also work on one of my favorite things, just because I guess it's a bit of a religion for me, astrobiology, the study of the origin of life. Biology is my background originally. I was an academic doing whale and dolphin work. My work was specifically around California gray whales. And that's another story, how I ended up going from academia to working at Apple, to working at Adobe, to working at Autodesk, and continuing to do oceans things, which I do to this day, and adding space things, which I added while I was an academic, by the way. We'll come back to astrobiology here. I was down in Southern California, and we were working on a project with JPL, and it was when I got a chance to meet Carl Sagan. As a matter of fact, it was back in the 1980s. Anyway, astrobiology, the study of the origins of life. And I can tell you, as a biologist, defining life is a bit tricky. You get different answers from different people, and people who know a lot about life. Generally speaking, one of the least common denominator answers to what is life uh, is it metabolizing? Is it reproducing? And is it reliably passing on information? There might be a few other things that some people want to add. But generally, things that do those three things, we say, yeah, that's alive. And it's fascinating to me. Two things here. One, that I can go outside and scoop up the molecules that are the same molecules that are in all of our meat sacks, and my meat sack and your meat sack, everybody who's listening here. And those are not doing those three things, potassium and carbon and just all that nitrogen, all the things that make us up. Um, and yet our meat sacks are doing that. And something happened. And that's special. Boy, that tells me just how special life is, especially as we are able to look back as collections of matter, collections of atoms, molecules that are able to look out into the deepest parts of our universe using other collections of matter that we have hobbled together to better understand the origins of the atoms that make all of us up. And that's a bit of my religion, because that's so special and amazing. And the science of trying to figure out what were the processes that happened that caused that to be, I find that journey to be absolutely fascinating. And there are other domains along the way, but that gives some idea of the amazing things that we get to work on at the NASA Frontier Development Lab. And after our first couple of years of doing the NASA Frontier Development Lab, the ESA, the European Space Agency, approached and said, hey, can we create a European Space Agency Frontier Development Lab? And so we have now for, I guess it's 6 years, been doing Europe FDL as well. With the European Space Agency and Oxford University. And one of the key components to the Frontier Development Labs are they are public-private partnerships. So the partners in this, in the US and in Europe, are a mix of these. And it's Google and NVIDIA and Intel and IBM and others who participate not only through doing some of the funding to augment the headquarters funding, and that's because we want to bring in, the way we do this is we bring in postdocs from all around the world every year. And you do interdisciplinary teams to work on these problems. So mixing planetary scientists with heliophysicists, with biologists, with data scientists, with AI specialists and other domains, and have them work on these challenges. And so those companies provide resources. So they provide, for example, NVIDIA provides us an incredible amount of hardware to do this work, because it does take a lot of that. Google provides us an incredible amount of TPU credits, so processing credits, so that we can just do what we need to do to get it done. They've been such amazing partners. And it's the most senior levels of these companies that are a part of these efforts to figure out some of these very challenging things. I'll use one example. Jensen from NVIDIA, the founder, CEO of NVIDIA, is one of the faculty members who is part of the NASA Frontier Development Lab as well. So very exciting stuff. I'm incredibly fulfilled by being able to not only have the privilege to work on some of these challenges, but to be able to get to know, work with, mentor these postdocs that are the scientists we need now and are going to need in another 20 years.
Okay. I am awed and jealous, but basically, your life is that of being able to express your child essence. In other words, the child in all of us the curious part of us, the part of us that's always learning and pushing the edge. I mean, you just rattled off mega projects at the level of protecting humanity and civilization, but at the same time, what it is you're doing is you're carrying us beyond the current edge. And I love the way you're doing it, the way you bring in the postdocs of different sorts. I'm a strong believer in throwing people of different specialties together. That's where the magic happens. And fascinating. Well, look, we're going to come back in a minute, and I want to get into your story, because somebody who's doing the things you're doing just didn't like wake up one day and say, this is what I'm doing. So I'm very curious to hear about the journey, and I'm sure the listeners are too. All right, spacers, we're going to be back in a few minutes with I almost want to call him Dr. Knowles, but that would be almost insulting, I'm sure. But
That's
Dr. Professor Knowles.
I've been both of those things, not a
Yeah.
physician.
No. Yeah, we're going to come back. You're listening to iRock Space Radio. We're part of the iHeartRadio network. My name is Rick Tumlinson, and we'll talk to you in a couple of minutes. Welcome back, spacers. This is iRock Space Radio, part of the iHeartRadio network. You are listening to The Space Revolution. My name is Rick Tumlinson, and our guest is Jonathan Knowles, man about the universe, and exploration director of NASA Ames Frontier Development Lab. So, John,
and I should correct you, at NASA headquarters.
At NASA headquarters,
as opposed to Ames.
Yeah, I'm sorry, headquarters, and you just happen to live near Ames.
I do.
Got you. So, okay, let's get into the story behind the man here. How did this all start? Where did your journey begin, John?
Oh, I have a good answer for you. Let's go back in time, back to the 1960s, and little Jonathan is watching TV.
Okay.
Meet Major Matt Mason, Mattel's man in space and the bravest astronaut yet. He lives on the moon. We may all be there soon. And he gets around with a jet. Until Sergeant Storm in his red uniform, Major Matt worked all alone. Now, together, they face the dangers of space and seek to...
So I had the Major Matt Mason doll. And you can look on YouTube and see these amazing Major Matt Mason commercials. And I had the space station and the Major Matt Mason and Sergeant Storm and his other friends that were astronauts and the sleds and all this stuff in the 1960s as a kid, and loved to play space. I mean, it was the 60s. It was space. We were on our way to something so very special that was about to happen. And I was in that whole world of being caught up in it as a little kid. It was what I played. And that was an important first start for me, was the U.S. space program of the 1960s, and was glued with my mouth open in 1969 when this happened.
60 seconds. Lights on. 6. Down 2.5.
Yeah.
Forward. Forward.
We know this audio.
40 feet, right. Down 2.5. Picking up
Neil's
some
grabbing Buzz is grabbing the stick.
Yeah, and they land. And it's astonishing. And we watch humans walking on the moon. And Major Matt Mason is coming to life for me.
Right.
And so now I'm super caught up in it. And, the next thing you know, this show on television captures my imagination in a way that was just overwhelming. I think we all know this one.
Space.
And that's all I have to play. And everyone knows what that is, I think.
Right. Of course.
That television show Star Trek. And I saw, this is a future for humanity that not only can I imagine, but I sure hope happens. Now, of course, as a kid back then, I thought maybe even in my lifetime.
Mm-hmm.
And to this day, I'm still a Star Trek fan. Two interesting things about the sounds I just played. I have gotten to know Buzz Aldrin very well over the last years. And that's been phenomenal for me to consider that had happened. And Rod Roddenberry, whose father created Star Trek, is a very close friend. And as a matter of fact, I met his mother and father the year before he was born at what was the second Star Trek convention in Southern California. It was the second Star Trek convention in the world. And it was that one happened to be in Southern California. My mother dropped me off, spent the entire day there, loved it so much, convinced her to take me again, and did it again, and met most of the actors from that show. And as a kid, went to the seminars, bought a Tribble, of course. Anyway, it's astonishing for me to think that, Rod has become such a good friend as well. So it starts out there. I grew up in Southern California, as I said, and this, I think, is a useful part of the story. In Southern California, in the neighborhood I was in, was sort of horse country. People in the hills there had horses, and a lot of Westerns, not just a lot. Almost every Western ever made was made more or less in our backyard, in the hills right behind where we were living. Most people know it from things like the movie Once Upon a Time in Hollywood. It's the ranch where Charles Manson was living, the Swan Movie Ranch, Iverson Movie Ranch. Those were in Chatsworth. So growing up in Chatsworth, most of the people there, many of them, were in the entertainment industry in the same way that most of the people I know here in Los Gatos are in the technology industry today. That's just how it is. It's close to where a lot of it is happening. And my high school, I was not sure what I wanted to do in life still. Science was definitely the thing I was considering most, but I was also into our theater arts program, and I was a member of our thespian troupe. And I wasn't into acting as much as I was directing, and I should say I was student directing, and that meant I hung out with our teacher who really directed, but he was a mentor in understanding, for me to better understand how that role worked when trying to tell a story to people. And so I would student direct for many of our things, and some of my high school colleagues who were also in our play production class were very good actors and went on. I mean, Val Kilmer, Kevin Spacey, Mayor Winningham were all high school colleagues in our play production class, as were many others who went on to write and act. Yeah, and that's just like people living in Silicon Valley would grow up sometimes and become people that are famous here in Silicon Valley. And so I think I started learning at that age about storytelling. And I found that to be useful. I ended up just choosing a career in science, in biology. The journey is so filled with so many things, more than what we can get in here today, but it involved me living in different parts of the world for sometimes lengthy period of times, including East Africa and Southeast Asia and South Asia. And I became a biologist. I ended up in academia. My original, and I was a computer kid. I forgot to say that. When I was in school, I was a computer kid. We were using HP mainframes via terminals, via acoustic couplers, early days, Apple IIs, any computer we could get our hands on, all the computers. Of course, I had Apple IIs, but also got my hands on everything you can imagine, all the different operating systems. And, especially back in those days, it was often, especially with the advent of personal computers, there was this vibe of, well, let's get the kid to tell us something, to help us with this. The kid knows about these things. And so that was the case in 1984 when we got a grant to buy computers. They said, hey, kid, what computer should we buy? And I said, oh, there's this brand new thing from Apple, and it's called Macintosh, and we should buy that. And we did, and I became absolutely enamored with this computer, and not just in the field of biology, but all the ologies. And very quickly, I was giving talks on how rapidly accelerating technologies can advance various sciences. I'd always been interested in astronomy, or at least ever since I got my astronomy merit badge when I was a kid. And started just hanging out with space folks in the 1980s. Ultimately having my bachelor party at JPL in the 1980s. That's another story.
So
Apple.
these are all kind of threads that are coming in. By the way, you and I we'll talk offline about it. We have way too much overlap
In common.
background.
Yeah. I'm not surprised, Rick.
From the Roddenberries, you know, and to the theatrical, to the, and
nice.
I remember walking into Rockefeller Center. USA Network was trying to start this new network, and they were going to call it the Sci-Fi Channel. And it was a very short period where I actually had to buy a suit.
Wow.
And I went to Goodwill, bought a suit. I called it my Letterman jacket because it had the double breasts like the old TV show guy. And I would walk in with my portable Mac in this big bag.
The Macintosh portable.
Yeah, portable.
Yeah, right.
And they would look at me like like I was from another planet, right? And I'm like, no, this is great. You need to use this. You need to use this. So you've synthesized all of these different threads into moving yourself forward, but then you actually go from, hey, Apple's a neat thing, to working at Apple.
So somebody from Apple saw one of my talks at a higher education conference on the I was talking about what I thought would be the future of these kinds of rapidly accelerating technologies, especially around computing, but others as well. And they said, hey, would you give a talk for us? We'd like to pay you to give a talk. And I said, sure. Are you kidding? I was such a fanboy. With a couple of friends of mine in Southern California, we had started a Macintosh users group that became very famous. Do you remember Macintosh user groups back in the days?
Mm-hmm. Mm-hmm.
So it became quite popular. We started it by plastering all over the place posters saying that we just had our first. Then wrote a newsletter about that first meeting and how phenomenal it was when we had never had a first meeting, and said, you don't want to miss the next one. And we had a huge amount of people show up for it. And fortunately, for a few years, we were able to, before we all moved on, able to do some amazing things with that. Very fun. To the point where Steve Jobs actually came down when he introduced Next. And we invited him to come down and do a head-to-head Next with the Mac. So after doing a few of these talks for Apple reached out and said, hey, will you come work for us? And I think that this is a key moment, because I started for the first time to realize something that I've now framed in the context of tool sets, skill sets, and mindsets. And I realized that the tool set piece of things, we've been doing tools for a very long time. I have a collection of Neanderthal stone tools. I have about a dozen actual Neanderthal stone tools. We've been doing tools for around 3 million years. And we got very good at it. And like with a lot of things with technology, there's a very long tail of that. You go along with the simplest tools, and before too long, somebody realizes, oh, you can chip it on both sides and make it a little sharper. But it takes a while to get there. And then a little further down, or a lot further down, you get to the point where somebody says, oh, no, you don't want to take the rock and chip at it to make a tool. You want to chip the rock in such a way that the piece that comes off is the tool. And you can see in the record, in the paleoanthropological record, anthropological record, paleoanthropological record, you can see that spreads. That, oh, that's better. Let's do that. And before too long, you get very sophisticated tools with very finely done. For instance, think about just the arrowheads that we're very familiar with here in the U.S. And little notches where they can be strapped to sticks and be used as arrows or be used as spears. And so tools, we've been on that journey for a long time. And now look at us. We have incredibly advanced tools, incredibly advanced computing power, sensors, AI, robotics, so many things. And so you want to spend some of your time on that and understanding what are the tools, where are the tools likely to go, but not the majority, perhaps, on tools. And skill sets, just about anybody can learn to do just about anything. Of course, some people will be better at others for different reasons. That word intelligence is not a specifically useful word, I don't think, anyway. We know, for example, there's no one group on Earth of humans that's more intelligent than another or more creative. Boy, that's another thing, Rick. I really hate that I hate to say hate, but this one I hate. I hate that we call people creatives and call people creators when in fact all humans are creatives and creator. Absolutely. And I think it's not useful to make some people think they're not. Anyway, skill sets, we can all learn skill sets. That the most important of those three things is the mindset piece of it. And that's very broad. Do you have a mindset, an open mindset? Do you have the mindset of, oh, I'm willing to try this other thing. I'm willing to take what I've learned on this journey so far and apply it to this other thing. Do you have a mindset of collaboration? Do you have a mindset of understanding that while intelligence and creativity are evenly distributed amongst humans around the world, opportunity is not. And so it makes sense for us to have a mindset of how do we provide more opportunity for more humans to contribute their creativity and intelligence to help solve some of the problems that we have. So, excuse me. Yeah. So
I'm going to break us now for a minute. We're going to come back and we're going to jump on that last part.
Great.
And apply it to space.
Great.
And we're going to do it in two parts. How do we engage as many people as possible with their different types of creativity in terms of what we're about or what we are about making happen right now in space? And also, I'm curious to see or to hear, also given our Star Trek background and all of this, your ideal sort of crew.
Oh.
Because I bet it's different than what people might think. All right, we're going to come back in just a couple minutes. You're listening to iRock Space Radio. My name is Rick Tumlinson. We're part of the iHeartRadio network, and we're talking to the incredibly interesting Jonathan Knowles. All right, Spacers, welcome back. This is the Space Revolution with Rick Tumlinson. We have Jonathan Knowles here. Major expert at everything. And we were having a great conversation about the kinds of people that you might send out into space on different kinds of missions to do different kinds of things. And so Jonathan, let's say you're sending a group of people to a planet, let's say Mars. I'm just picking on Mars. It doesn't have to be Mars, but that they're going as precursors to other people coming later. And what kinds of mindsets, what kinds of people, skills or skill sets would you want to pick to put on that crew? And how would you have them, what would the framework be within which that mission would occur?
Well, definitely with regard to skill sets, we would need the people who know how to do things. And know how to follow the instructions, but also know how to do things in case all of a sudden we lose the instructions, right? We need people with those kinds of skill sets. They've been trained. And we've seen this before, right? We sent astronauts to space in the 60s and had one of them get out of his capsule, and it turned out to be not so good because we'd never done that before, and there weren't any handles on the outside for that astronaut to hook onto. And so we came back and we figured out, oh, we got to do this other thing. So we need people who know how to approach these kinds of simple problems like that, as well as the more sophisticated versions of those things. I would absolutely start with the following. I encourage everyone to take a look at a study that was originally initiated by NASA through a psychologist named George Land. The study he did was fairly revolutionary. He created a creativity test, and it's unlike an intelligence test. They're not very helpful all the time. But this test was very different from that. It didn't test what you knew. It was things like list in 1 minute all the things you can do with a brick. And and they got some great results, and you can read about those results and how it helped NASA. But many other researchers have since taken on and built on the George Land study, and they've consistently found similar results to this. They do these creativity tests to 5-year-old, 10-year-old, 20-year-old, and then adults. And here's what they find. Very consistently, these results, they find that 5-year-olds, take a guess as to how high out of 100% 5-year-olds score on this creativity test. Wild guess.
75.
98%.
Wow.
And if you really think about it, right? And I know you've spent time with kids, and so they just come up with all kinds of ideas. It's fabulous it's joyful to see that come out in them. Things that make you go, oh yeah, well, yeah, that could work. So they consistently get about 90%. By the time children are 10 years old, take a guess what they're scoring on that creativity test.
I'm going to guess it's starting to drop.
Yes.
I'll let you tell us how much.
30%.
Wow.
Exactly. Wow. By the time they're 15, it's 12%, and adults, 2%.
So diametrically opposite from the child to the adult.
Something is happening and it's not biological. It's not that somehow your biology is not allowing you to be this. Something in the way we do the life journey through culture and education and all the things on that journey that help form us. And you can see how this would be helpful for NASA. This is probably going too far to say this, but we beat the creativity out of humans on that journey. And that's less useful to have that. And so it doesn't have to be that way. That's another thing that we found, that there are ways to make that not true, to instead foster it. You know, that old saying about think outside the box. I know what people generally mean. Again, a not very helpful phrase in my opinion, because I think it's better to, as much as you can, deny the existence of a box. At all, and really foster and mentor a sense of creativity and help apply it towards solving the problems we do. And I'm going to come back, when you talk about crew, I'm going to come back to Star Trek for a minute. And this is certainly true. I think I can speak to the original series, The Next Generation, and boy, am I a fan of Strange New Worlds. Wow.
Oh, yeah.
Oh man, I didn't think I'd ever say that when someone asked me the question, what's your favorite Star Trek series, that I would say that I would hesitate. But now it's really right there. It's like asking who's your favorite kid? And for me, it's Strange New Worlds and the original series. And one of the things I think those two series and The Next Generation show us often is that the mindset of approaching problems in a, first of all, creative way, not having people who haven't had the creativity beaten out of them or taken out of them or fostered away where they haven't exercised that mindset muscle over their life journeys. Along with all the other good things that we know, that collaborative approach, that inclusive approach. Yes, even Vulcans and occasionally even Romulans and Klingons might be able to help us solve this challenge that we have, and really understanding the value of having those different life journeys and experiences participate in solving those problems. So I would want a team of people who were quite diverse, not in their um, this creativity piece that we're talking about here, but in their life journeys that got them to this place. People who've had challenges that some of the others didn't have, that had to come up with um, novel ways of solving some of those challenges because of the life journeys that they were on. And I
Can I
think,
just for a
yeah,
second there? I want to jump on that just for a
sure.
second because you've identified a fallacy that occurs in our public discourse when we're talking about inclusion and diversity. And the fallacy is that, in terms of how it makes an organization better or how it makes, you know, your space company or whatever it is better, it's not that somebody has a different color. It's not that they have a different gender identity. It's not any of that. And it's all of that. But what it's really about, as you're saying, is that because they're coming in through different life pathways and they've had to deal with different challenges and overcome them in different ways, they're actually, it's not just you're doing it so you can look out at your company and go, oh, we've got a rainbow. It's that you've got this amazing amount of different kinds of creativity to apply to all the challenges because it's coming from all these different sources. Is that what you're saying?
It is. And I should say also that I do believe that we've done such a poor job of doing this over the centuries or millennia that it is important for us to recognize that we've done that poor job and recognize that we need to be open to and actually take what are sometimes seen as the bold moves. I got to know Nichelle Nichols a bit um,
Great.
before she passed away and spend time talking to her. And I learned a lot from her around what a big deal that was for her just to be on that show.
Right.
And have the role that she had on that show and do and say the things that she did as an actor on that show. And now we see things like some of the NASA astronauts who were inspired by her, who saw that and said, oh, I can do that too then. That's like me. And so, yes, and all the things you said, and yes, and let's acknowledge what we've done poorly and do a better job of really making sure that we are providing the opportunity for everyone to participate. You know,
But we're not just doing it to provide the opportunity. To bring this back to what you were saying, it is additive in terms of the solution sets that we're able to come up with
absolutely.
when we're facing challenges, because we're getting these other perspectives that are, maybe they've got a different percent of that. If all we've got as adults is like 5% of our creativity left, at least maybe they've got a different 5%.
Exactly. And we know that there are many institutions, government and private and academic, that say, here's the way we do things here. And when we really understand this notion of intelligence and creativity are fairly even distributed all around the world, who knows what we are missing out on by not including more of those people who might just be some of the ones who have the opportunity to add incredible value. I'll use as an example here, Sylvia Earle. For people don't know who Sylvia is, she's the Carl Sagan of the oceans. Um, or even more perhaps than that. And I've had the good pleasure to serve as her science and exploration fellow at Mission Blue, a phenomenal organization. And when you get to know Sylvia and understand her journey just as a woman, she's in her 80s now. A couple of stories that she tells that are fascinating. She was in school at a time when plate tectonics was still not all scientists were convinced, and she would have male professors who tell her, don't you ever write about that again, don't ever bring that up again, that's absolutely hogwash, this thing. And she went to do an interview for a postdoc job, I believe it was. Sylvia Earle, this is shocking. You can't go to a streaming service and not find a documentary about her or an oceans documentary featuring her. And she was told, oh, little lady, we only give these jobs out to men because you women are just going to get married and have kids and not go on. And thank goodness that Sylvia at least had the mindset to persevere and go on. And when we look at the accomplishments that she's made and the inspiration she has been to so many other women in the field of ocean science. And that was particularly interesting because to this day, I constantly meet adult women who say, I always wanted to be an ocean scientist, but then, anyway, so we don't know what we're missing out by not casting that wide net. Really wide. Yes, and all the things you said, and yes, and not a but at all. Yes, and with the mindset of, well, why are we doing this? And I approach it from, we're doing it to make it better for more people here. So more people here have more opportunity to participate to help us get to, and I understand that it's not, I understand what I'm saying when I say this, a Star Trek future, right?
Right.
Where we have, and people can have broken Star Trek apart and saying, well, here's where they didn't do all that. And, I did a lecture a few years ago on alcohol and Star Trek. And as you research that, you realize, oh man, those guys were terrible. Like they would have Scotty drink and he'd get in fights all the time. And Kirk would drink and he would absolutely molest women. But the basics of the good parts of that Star Trek future that we see. And I think that's how we get there faster, by the way, is by having that kind of inclusion and, like you say, diversity of backgrounds, life journeys, all of it, all with the creativity released in them, their ability to, and I should say, I've been a part of some amazing teams over my 30 plus year career in Silicon Valley, amazing teams of people. And I put all of my success down to the teams of people that I have been a part of, where I can absolutely see what all the different team members have contributed to making the thing happen the way that it did. It was a phenomenal moment for me when I found myself actually working directly with Steve Jobs at Apple. This is when he came back to Apple. And again, I was a fanboy. And just like with Buzz Aldrin and Rod Roddenberry, and that list is hilariously weird. I think that I've had the opportunity to meet and get to know some of the people who are my heroes or people that directly influenced my life. So yes, inclusion, diversity for the reasons that you said, to make it better for people here. And I believe that one of the ways we do that, and this is why, I was involved with Made in Space. And that was our whole thing for Made in Space in the first place, was, can we move manufacturing out into space where we don't have to pollute and make things here? Can we ultimately mine asteroids, the moon? Can we, instead of the ocean, I'd much rather see us do that. How do we get there faster so that we're getting the resources we need from places outside of our planet here? And then how do we make them in either ways that don't mess it up, or in places where we don't have to mess it up? And sometimes these are hard things to do, and they're hard journeys, and you have to have that one of the skill sets here. Here's a skill set specifically to that question. People have the skill set to be able to zoom in tight on a problem and work on it at the nth degree, as well as zoom out and look at the big picture for why we're doing it, where we're going, what's likely to happen because of what we're doing, so that zooming in and zooming out to look at things as you're solving problems would certainly be one of those skill sets. And I see people who are very creative often have that capability to do that. And I think we can do it, right? Small starts. With Made in Space, we started by saying, let's just send a 3D printer to the International Space Station. Mm-hmm. And then, which, by the way, is tricky, right? 3D printing generally wants gravity. We've all seen 3D printers work, and they expect gravity. And so it's tricky to do a 3D printer in a microgravity environment, and then do it again. And by the way, we've had an open mindset about this with the goal of, can we do this kind of thing off-world? And we learned things that we didn't expect to learn, for example. And those kind of things come up when you have people who are open to being open, to having an open mindset.
So we're going to have to take a break here, but having an open mind, not recognizing the box,
Yeah.
being willing to try different things, being willing to be a part of a team that has a diversity of not just points of view, but approaches to challenges. The Zoom in
With
people,
respect and candor, right?
And
Those
of
teams
course,
that can do those two things. I know it goes without saying, but sometimes it's important to say.
it's absolutely important to say. Unless I'm on the team, in which case I'm always right. And on that note, we will be back in just a couple of minutes with our guest, Jonathan Knowles. You are listening to the Space Revolution. My name is Rick Tumlinson. We're part of the iRock radio station, and which is a part of the iHeart Radio Network. All right, Spacers, welcome back to the Space Revolution. My name is Rick Tumlinson. We have an amazing guest, Jonathan Knowles, who is, oh my God, undersea explorer, worked with Steve Jobs. Some of the stuff you use on Adobe, he helped lead the teams that created those. Working with NASA headquarters, working with AI, pretty well everything in the universe. He's touched his hands to at one point or the other. So, Jonathan, we're coming up in the last quarter here, let's say. There's a lot happening right now. And it's funny, by the way, you mentioned the event in the 1800s when we had the solar flare. And what was interesting, of course, the highest electrical technology we had at that point was basically telegraphs. And those got fried. So you can only imagine what would happen to our society if one of those things happened now. But that's sort of an immediate, oh my God, look, that thing's happening. It's coming at us. Same thing with near Earth objects or asteroids. And I do recommend we look at people should go watch the film, Look Up. It's hilarious.
Definitely.
An important lesson. But we're doing this, we're in this very interesting period where, and I do talk about this at times, where the same technologies that if, people, I'm sure by the time they hear this, will have seen the movie Oppenheimer out in the world or whatever. And the same technologies allow us to destroy ourselves. The same technologies that allow us to press a button and wipe out the planet or slowly do it in the way that we're doing it now are the ones that will open up the frontier. And as we open that up, we have the chance to use what we're doing out there to help save the planet. So it's all very much focused in, I believe. One of the things I've talked about is that we may be nearing the end of the most important 100 years in human history. If you take the 30s and 40s of the last century and all the things that happened within a 10-year span of that, the world wars, the atomic bombs, the rocketry, computers, global plagues, all of those things. And then you bring that to this next 10 or 20 years. We're coming at something here. At the same moment, we have, our crazy friends like Elon and Jeff and others building these rockets that are potentially going to be able to help broke us into the solar system. It's all happening right now. What do you make of that? What is the opportunity? What is your fear? What do you make of it?
Well, I'll come back to fear, I think. I'll have to really think about fear because I really do try to remain a cautious pessimist. And actually, I mean, cautious optimist. And really what I think of myself as is a possibilist.
Like, ooh, I like it.
Just approaching things that way. And I do it from the perspective of we have had these incredible moments throughout our existence as Homo sapiens sapien and before with our ancestors. But more recently, some of the things like the invention of the alphabet, the ability to not have to draw pictures, but to actually have little characters that can be sounds so we can communicate all of a sudden way more information. What an incredible insight that was. And boy, did that ever change things in such a big way when that thing happened thousands of years ago. But even as recently as 100 years ago in 1923, when there was an astronomer, who was looking up out of his telescope. And the big thing to find in 1923 for astronomers were variable stars. Everybody was looking for variable stars. That was a big deal. And he thought he found one, and they used to take photographs and develop them on glass plates. And I have a replica of the glass plate from 1983. I'm looking at on my desk right here, right now. And it says VAR in capital letters and exclamation point, because he thought he found one in this photograph from 6th October 1923. He's written on the glass plate. And within a very short time after taking this and looking at this photograph a little more, this astronomer realized, hey, wait a minute, that's not a variable star. Now, up until 1923, the entire universe was the Milky Way galaxy. That was the entire universe. And all of a sudden, this astronomer said, that's a galaxy. And boom, we went from the entire universe being the Milky Way galaxy to the entire universe being maybe, and this is kind of hilarious, maybe dozens or hundreds of galaxies out there.
Ooh, dozens.
Dozens, hundreds, thousands. We know that number is significantly bigger. By the way, that astronomer was Edmund Hubble. And ta-da, wow, what a moment in our knowledge of how things really work. So, and there are many examples. You can pick the things along the way that you think are these momentous insights or discoveries that we make that help us move things forward. Generally, the things that help us to better know how things really work, they're the things I focus on the most. And I have an open mindset to say, what are the future versions of those things that we haven't even come up with yet? A few people maybe were thinking things like, maybe there's more than what we think there is. We used that thing called science, that method, that process, and determined, there is. And so there is likely to be a whole host of other things that fall into those kind of categories. And as a possibilist who is focused on what an amazing, wonderful place we have here right now that we have evolved to live in, and a deep understanding of everything else wants to kill you. Mm-hmm. Maybe it doesn't consciously, but you die in orbit unless you do certain things. You die on the moon, you die on Mars, you die in cislunar. When we're out there, it's tough out there. That doesn't mean we don't go. That just means that it's useful for us to understand how things really work. And I believe that we can make things better here by doing one of the things that we do best. First of all, we're creative. That's one of the reasons we are, as a living thing on this planet, where we find ourselves today. And we are also, because we are creative, I think we are curious. We are explorers. And it's like creativity. Everyone is an explorer. That's what you do. When you're born and you're a little baby, you're reaching out. Your hands, they go out from you. You're exploring the space around you. When you can move, you're wiggling around, exploring. We spend our entire existence doing that. And I think that is phenomenal. And I think that's the thing that is going to ultimately help us to, in some way, be more than just the 6 billion year existence that we know we can have here in this solar system, because we know how the sun works. We know there's a time clock on our molecules here. In the shorter term, we can do more things in our solar system, and perhaps, and I get very open to the possibilities here, perhaps our long-term us is the us in digital form represented. I'm hesitant to say AI because of the way that phrase has come to become things now. And I've had the privilege of knowing Marvin Minsky, who, along with John McCarthy, came up with the phrase artificial intelligence. Marvin, an MIT professor. Interestingly enough, those guys said back in the mid 1950s, they said, I forget the number. It was like, give us $250,000 in a couple of years and we should be able to create a computer that is like the human brain. So we do make these hopeful statements every once in a while. But thank goodness we keep on being curious, and we keep on exploring, and we keep on trying to find out. And perhaps we can go on to do so many, many more things, and perhaps even have a legacy that lives beyond the 6 billion years. That's another thing we can talk about. I served on the SETI board of trustee for a number of years, where I was privileged to share an office with Frank Drake of the Drake equation.
Oh, I know Frank. Yes.
Yeah, he just passed away a little less than a year ago, and so I am hopeful for our humanity's future in space. I know you knew Gerard O'Neill.
Mm-hmm.
The High Frontier book, of course, was influential for me as well. I hope that we can do the things necessary to actually realize some of this stuff. In business, there's the talk of strategic intent and strategic realization. And I think Jerry was good at describing a strategic intent. And often we need to sit down and do some of the hard work and apply our skill sets to the strategic realization piece of that. On that note, I'm sure you know Rick Gaitis.
Mm-hmm.
Rick did some of those amazing paintings. He's an artist here in Los Gatos and has lived here since the 1970s. And he's my neighbor and my good friend.
Wow.
And it's wonderful to be able to meet and talk to people like that as well, who are able to have the skill set to help us visualize. And he did this in the 70s before we had all the fancy Autodesk Maya software that Jim Cameron uses to make Avatar and other things. And he just painted those wonderful things. And so my long-term hope is that we can realize that inclusive future way beyond the limits of this world, and always do it with that mindset of protect this place, the place where we evolved.
Yep. It all starts with the mother world. And look,
It does.
I mean, clearly, we were inspired by the visualizations, the verbalizations, the writing, whatever. And I'm going to ask you a couple of the goofy questions. They're not that goofy, but I like to ask them because I'm always enlightened by people's answers, and
Sure.
just real short answers here as we start to wrap up the hour. And that is, the first one is, you're cruising over your planet of choice. It could be the moon, Mars, it could be the Earth, the mother world. You're cruising pretty fast. You get that sense of speed. You can feel it passing below you. And you're in your capsule or whatever it is. What music would you be listening to?
Oh, no question. Holtz's Jupiter.
Oh, there you go.
I mean, everyone go listen to that. All of the music in that work that he's done of each of the planets, but by far, Jupiter, that's an easy one for me.
The 9-Planet Symphony.
Yeah.
Perfect. What book would you say, fiction, I'll specify as fiction for now, influenced you the most in terms of space itself? I mean, you've had so many influences and worked in so many areas, but in terms of space itself, which one?
Yeah, that one, I guess, is a little tougher because I don't read a whole lot of fiction. I do some, and I have. I used to read more. On that front, by the way, I was a big Hemingway person. So his works influenced me. It's what I was, taught in school to read. And speaking of the life journey, his grandson John is a good friend of mine, John Hemingway, and I.
Everybody on the planet.
We've been to, we've done all kinds of fun stuff together. John, yeah, he's a great guy. Check out his book, Strange Tribes, people. It's a good book. I guess from fiction, it would probably be, I'm going to say 2001, A Space Odyssey.
Okay.
Yeah.
And nonfiction, we'll jump over there and help you with that one.
The Grapes of Wrath by John Steinbeck. He wrote it about a mile from where I'm sitting right now here in Los Gatos.
Mm-hmm. And in terms of space, science.
In terms of space, I'm doing nonfiction now. No, I'm doing fiction.
Yeah, nonfiction.
Nonfiction. Oh, okay. I misunderstood that. Let me get this right.
No
Nonfiction space book. I think it's still the high frontier.
Well, there you go.
Yeah.
Just earning points with me there on that one.
Yeah.
And was there a movie or TV show? I think we've already touched. I think we've got that one figured
Yeah.
out. But
It's Star Trek, the original series, and Strange New Worlds. Loving both of them. Loving Strange New Worlds.
Absolutely. And so,
Although let me say,
go ahead.
I wish they didn't have quite so much the graphic violence. I've always been adverse to graphic violence. I get that that's what you need to do to get eyeballs on things these days, but I wish that weren't true. And I feel like if we could just have everyone slow down on the graphic violence, we would have less of it in general. So I'll do it with that caveat.
I agree. We've crossed every line, and we keep crossing them, crossing them, and crossing them.
Yeah.
I think maybe we'll come back to like, hey, maybe we'll just describe the violence like they did in the old Greek plays, and go from there. So, very not quickly, take your time at it. If we have a different audience, and it's worldwide, and in my case, in our case, we have one person on one side of the world, one person on the other. So we have two people. We call that worldwide listening. Hopefully we have more than that. But if you were talking to somebody who has an interest in getting involved in the space field in particular, in the revolution in particular, what would your parting wisdom to them be?
It would be the same regardless of what the domain they wanted to pursue in their life. It would be to focus on mindset in everything you do. It sounds easier than it is to do, right? So much of our culture, especially Western culture, but others as well, is focused on defining who you are by your skill sets and by the knowledge you have and expertise you have with tool sets. And I would love to move away from that. In America, especially, it's like, oh, what do you do?
Yeah.
And we say, even to our kids and grandkids, we say, what do you want to be? And I hope that we could get to the point where the answers become less astronaut, pilot, doctor, scientist, and more, what do you want to be? I want to be kind. I want to be friendly. All those other things that fall under that mindset. I want to be compassionate. If we can get more humans who say what I want to be are those things, then I think they'll be so much better at what they do and certainly more useful at what they end up doing than otherwise.
I think
And by the way, you know what? I'm
Go
gonna come back on the book thing. Anything by Carl Sagan.
Okay, there you
Just
go.
anything by Carl Sagan book wise. But I do think focusing on mindset. Focus on mindset.
Mindset. What is your joy? What is your dream? And how
Yeah.
will you approach it?
Yeah.
So I have to tell you, Jonathan, our shows sometimes are very technical. Sometimes they're, we talk about business, space business, this and that and the other. We talked about everything on this show today with you, and it's been a great pleasure. I look forward to having you back at some point, and maybe we'll pick a topic and zero in on that next time. But thank you very, very much.
I'm grateful for you doing what you do with this, Rick, because I think that the more people that can hear the kinds of things that you're talking about, the better we are at getting to where that Gerard O'Neill future can be.
Oh, thank you very, very much. So, my fellow spacers, another episode comes to its end, and we are out the airlock.